In this video I'm going to show how I rendered my images that I collected of my scanned object. So in this folder I have all the images, and I pulled this off of my Raspberry Pi. And so at the top you can see the angle measurement. So the 300s is because we aren't taking any measurements to be negative. So we're going to go from 0 to 360. And so in the middle of the image you can see my laser, a little red laser right there on the object. And the Raspberry Pi is just going to use some geometry that we talked about to determine the distance from the camera that the object is, and corresponding to that laser's position on the object and on its frame of reference. So here in the code, you're going to see those are two upper bounds and lower, no, it's an upper bound and a lower bound, and that is for colors. So it's going to read this file, and it's going to be pulling all the images out of the file, and the bounds on those colors is going to describe how we mask our image. So it's going to filter all the red from the image. And this line of code here is going to demonstrate it pulls that angle measurement from the image, because each image is named with that angle measurement. And then right there we're going to mask our image. And this mask, like I said, it's going to filter out, it's going to filter all the red or all color that isn't red out of the image. And it's just going to leave the red stuff, or the red color. But it's going to, instead of it being red, it's going to translate it to being white. And then everything that isn't red in the image, it's going to translate that to being black. So this way we've effectively created a filter over our image that just filters everything out except for red. And this makes it easy for computing processes and determining where our laser is in reference to our image. So we're going to go ahead and run the code, and this is going to go through each image, and I'm going to show you a picture of what our mask looks like in the end, and it will be a black and white picture where white is the location of the laser. So here in the center you can see that white. That is where our laser is in reference to the camera. And I'm going to press a wait key to go on to the next image. The next image, we didn't move very far from the last one, so it should be relatively the same location, or it should look pretty similar. But here we're starting to make moves, starting to make a difference. So you can see on some areas on my object, the laser just shows up better, either because the object is a little bit lighter in that area, or the material, the sort of finish on it is a little bit more conducive for the laser to show up properly. Here you can see the rounded portion of my object, and that laser is just slowly curving, and you can see where it's curving towards the center of the frame means that it's a little bit further away. And so every time I go through one of these images, the computer is just running a for loop through the rows and columns of the pixels and locating where in 3D space the object, each point on the object is. Now this is going to get loaded into this test results file, and in this test results file you can see those three columns in reference to their individual locations in 3D space. And we're going to end up using all these numbers here. We're going to have MATLAB read all three columns, and MATLAB is going to process that data into a 3D map of our image. Now on the MATLAB. And MATLAB is just going to read that text file for us. So you can see right there it's importing the text file information. And then it's just going to read the columns and rows and sort it into usable data and plot it. And so our plot will look something like this. Now this may not mean a lot to you, but for me it shows that there's a little bit of a misalignment. This area up here you can see is where that curve was, so we know that we're mapping something correctly and we're getting okay data. But there is another area on here that you'll notice should be completely flat, and it isn't. It's actually sloping. So there must be some sort of misalignment with my laser, and I did need to make a laser adjustment before before taking this data. You see that area there highlighted in yellow, and the realignment that I performed, in the middle of things, probably was the reason for this. So later on, we're going to make sure that when we go out into the field, that the laser is perfectly aligned before doing so, and there will be no issues or adjustments that have to be made while we're out there. And hopefully that should resolve that sort of sloping issue that we see. We also see that it's sort of stretched on the bottom. So this object shouldn't have as much depth as it looks towards the bottom. It may be the case that it is like that, but I'm fairly certain it isn't. And this is probably also from that sloping issue. So when we go out into the field, we'll make sure that everything is completely adjusted perfectly beforehand, and then retake our data.